We've had a request from one of our online students who felt that the book did not explain, or the software did not explain piecewise defined functions adequately. And so I decided to give you a problem. And this is probably one of the more difficult ones. There are some in the book that are probably a little easier than this one. But a piecewise defined function is just the way it sounds. It's defined in pieces. It's defined a certain way over part of this domain, something else on part of others domain. This part on the right, when it says x is less than -2, the function is defined to be 2x minus 1. So if you know 2x minus 1 is a line, and it's only defined to be when its x is less than -2. Now, when x is between -2 and 1 inclusive, which means it includes both the endpoints, the function is defined to be x squared, and that's the shape of a parabola. And the third one is defined to be a constant, which is just a horizontal line when x is greater than 1. So what I do is I use these as the breakpoints. And so at -2, it's defined one way and it changes. And at 1, it changes over to something else. So these little dotted lines I am drawing, if you're very familiar with something called asymptotes, this is not an asymptote. These are just breakers. Okay, so on the left side of -2, it's defined to be 2x minus 1. So I put 2x minus 1 down there just as a reminder. That's what it's defined to be over there. Between -2 and 1, like we said, well, it's defined to be x squared. So I put x squared there. And on the right side of 1, x is greater than 1, it's defined to be 4. So basically, you'll have 3 graphs. And the graphs cannot overlap these dotted lines. So once a graph is on the left side, it's got to stay contained on the left side. Same thing in the middle and same thing on the right. But the 2x minus 1 is a line and has a slope of 2 and a y-intercept of -1. Of course, the y-intercept is not over there. So what I would suggest is just find a point over there. So if you plug -3 back into the function, okay, -3 is less than -2, so you plug it into this one. Okay, so it'd be 2 times -3, which is -6, minus 1 is at -7. So it's -3, -7. Now -7 is way down here. So I might have to extend this just a little bit farther. So -5, -6, -7. And so it's -3, -7, which is a point right there. Okay, and the slope is 2. So you use the slope idea, rise over run. So we'll rise 2, 1, 2, and run 1, which is right there. And 2 points determine a line, like we've learned in high school geometry. Now that is 2x minus 1. Notice once I got to the dotted line, I stopped. I didn't extend the line past. Okay, because it's only defined to be 2x minus 1 on the left side of -2. Actually, it's not even defined at -2 there. So actually, we're going to put an open circle there to indicate the graph is not defined at that point. Now, between -2 and 1, it's defined to be x squared. So it's a parabola. So if you put a 0 in, because that's a number between -2 and 1, we'd plug it into 0 squared, this function, part of the function. So it's 0 squared, which is still 0. So there's a point at the origin. And you can do a few other points. If you're not familiar with what x squared looks like, it is a parabola. But if you're not familiar with that, you can plug another number in there. -1 is between these two numbers, so when you square it, it's 1. So -1, 1. So if you get enough points, you'll notice it looks kind of like that. Okay, so then at the ends, they're defined because it says between -2 and 1 inclusive. So there's a point there, and it goes over here, and there's a point there. Notice they're not open circles on this one because it's inclusive, which basically means you include the numbers. So that's why it gets a solid dot. Now on the right side of 1, it's defined to be a -4, which is a horizontal line. So if you plug in, let's say 2, it stays constant of a -4. If you plug in 3, you get -4. So 2 gives you -4, 3 gives you -4. So like I said, it's a horizontal line. But as you can probably start telling, that this is the reason it's called a piecewise defined function, because it's defined in pieces. But notice this one's getting an open circle as well, okay, because it's not defined at 1. And so, so this middle part is part of a parabola. and it's only defined between -2 and 1. So, but anyway, these little dotted lines, you can erase them, you can leave them. I really don't care at that point. A lot of people don't like them there because it's not really part of the graph, and so they'll remove them. But I would suggest that you leave them in here, at least temporarily, so you'll know not to extend past that point. So a lot of times when people will start graphing these things, they'll extend this line farther than it needs to be. And as you learned earlier in chapter 3, this is not a function because it fails the vertical line test. Because if you draw a vertical line through here, it fails the vertical line test. So it's not even a function to begin with. So you got to be very careful not to extend that. Okay. And if you have a specific question on a specific problem, just send me a video clip request, and I'll see if I can help you with that one.